From the American Neurological Association, I'm Adeline Goss. This is ANA Investigates. Look around you right now and think for a minute about all of the things you're exposed to. The coffee you're drinking, the mug holding the coffee you're drinking, the soap that mug was washed in, the sleep you got last night or didn't get. All of this is part of what we now call your exposome. And as we're learning, the neural exposome influences our risk of developing a range of neurologic diseases. Our guest today is Dr. Eva Feldman, the James W. Albers Distinguished University Professor and the Russell N. DeYoung Professor of Neurology and Neurosurgery at the University of Michigan. She'll talk to us about research on the neural exposome in neurodegenerative disease and what we should be telling patients and policymakers about this research. Dr. Feldman was interviewed by Dr. Vinita Acharya, Professor of Neurology and Distinguished Educator at Penn State College of Medicine. Here's Vinita.
Welcome to ANA Investigates, Eva. It's so nice to have you here.
Well, it's wonderful to be here, and it's wonderful to speak to you.
So, exposome, the term is getting a lot of interest, especially the neural exposome. Eva, can you get us started by, say, somebody who does not know the term at all? How would you explain to them what is the neural exposome?
Here, I'll start with what is the exposome, right? And then we'll go to the neural exposome. So, the exposome is just the totality of all the environmental exposures that you have undergone from birth till currently. So, from the minute you are born, and even in utero, you are exposed to multiple outside factors. So, the neural exposome is then all of those factors that can affect brain function. And it's really everything, which is what makes it so fascinating. It's diet, it's exercise, it's all the environmental pollutants, it's the air you breathe, it's what you touch, what you put on your skin. So everything that you are exposed to is the exposome, and everything that affects brain function and that large myriad of factors is the neural exposome.
So, what is the advantage of thinking about all of these exposures in aggregate?
Well, because you and I and everyone listening to this podcast, as we, for example, are in our car driving along, we're listening to a podcast, we're breathing air, which is likely polluted, we're holding on to a steering wheel. So you can't think of one sort of exposure in isolation. Now, realistically, we do study and have to study exposures in isolation, but we always have to factor in that you and I and everyone is not exposed to just one thing at each time. And then they interact with each other, right? So they're very, very interrelated.
Can you tell us how the neural exposome, how does it interact with genetics and epigenetics?
Certainly. So we'll start from the very basics. So we're born with a set of genes, and those genes contain the code to eventually give us enzymes that help us detoxify pollutants and toxins in the environment. Pesticides, herbicides, again, pollutants that you breathe, what you ingest. So you have a set of enzymes. You're born with those. And really, depending on what your genetics are, you may be better at detoxifying, say, a negative pesticide than someone else. So that's the genetics you're born with. But what's really critical, and what we know now for many of the neurodegenerative diseases, is what these toxins do as you're exposed to them throughout your lifetime, is they actually make what are known as epigenetic marks. And what that is they change then the structure of your DNA. They usually methylate, cause methylation in your DNA, which then, of course, downstream has the consequence of then changing your ability to make the correct enzymes for detoxification. What's very interesting is if you look at then these epigenetic marks are then marks made on your genetic code by the pollutants. What you will see in someone with a neurodegenerative disease, ALS is an example, is you see an advanced aging. We're all born with a certain genetic age, And when you get enough negative epigenetic marks, while you may be, for example, 60 years old, your epigenome and your genetics and DNA make it as though you're 70 years old. So it's really important, these epigenetic component to the whole exposome story and to our understanding of the intersection between the exposome and neurodegenerative disorders and brain health.
Your research is focused on ALS, and since you brought up the ALS, can you tell us some of the key risk factors and progression in relation to exposome in ALS?
So what we have shown is as follows. There's a clear increased risk of 2 to 3-fold minimum secondary to environmental exposures, which are these persistent organic pollutants. So these are lubricants, gases, solvents that are in the soil, in the air, and in the water and last for hundreds of years. In particular, the pesticides, for example, DDT, which I'm sure most people have heard of, its byproduct DDE is in the soil, water. We're constantly being exposed. That lasts also hundreds of years. And those types of pesticide, those organochlorine pesticides, increase your risk of ALS fivefold. Secondly, if you look at survival, and then you calculate what's known as an environmental risk score, where you look again, not because you're exposed to one of these pollutants, but you're exposed to many at one time. So you look at hundreds of pollutants and you calculate an environmental risk score. The higher your environmental risk score, meaning the higher your exposure, the less your survival once you're diagnosed with ALS. Finally, another very interesting piece of our work is that these exposures intersect with your occupation. So individuals who are welders, who work on the line, or production workers, those individuals have a higher risk of ALS, in large part because of the exposures that they naturally have in their occupation. In fact, last point, we're pleased to say that the Center for Disease Control has funded us to look at 4,000 individuals, primarily production workers in the state of Michigan, now healthy individuals, about the average age of 50, and follow them for the next 20 years. Look at all their exposures to better understand the association of these exposures to ALS, when an individual will develop ALS, and what their trajectory will be. So it's the first in kind prospective population-based study looking at ALS and the exposome.
So, Eva, you have also written about the neural exposome in Alzheimer's and Parkinson's disease. How would you characterize the role of the neural exposome in these conditions?
Of course. So first, the general idea is the same. You have a genetic predisposition to being able to detoxify all the pollutants that you are exposed to. You then get epigenetic marks from certain pollutants and exposures that make you more susceptible to develop Alzheimer's or Parkinson's. Interestingly, Parkinson's has some very specific pesticides that the disease is associated with. That's rotenone, paraquat. They've been very well studied. It parallels with data showing that individuals who work in the fields, for example, in California, picking fruit and doing jobs where they're exposed to those classes of pesticides, have a higher incidence of Parkinson's disease. And there's been very nice work done on the basic mechanisms also of how these particular toxins are more likely to cause brain damage in those areas involved with Parkinson's disease. So that's PD. Alzheimer's disease is a very similar story, but in a way, even, I don't want to say more interesting, but the Lancet Commission in 2024 put out its new report, and they reported that 45% of Alzheimer's disease is it attributable to modifiable risk factors? 8% of that was air pollution. Isn't that amazing? Of course, then there are the other modifiable factors. There's diet, there's exercise, uncontrolled hypertension, and all of those factors are part of the exposome, correct? But air pollution is attributed 8% of the risk of dementia. And people are very actively trying to understand why that is. But there's a very, very strong association. Occupationally, the military has been found to have a higher incidence of both ALS and Alzheimer's disease. And then smoking, another part of the exposome, is closely linked with Alzheimer's disease and also with ALS.
What are the primary challenges in measuring and analyzing environmental exposures over a person's lifetime, and how can researchers address these obstacles?
Well, I will tell you, we have an NIH Director's Transformative Award that we received when Dr. Francis Collins was the director. It's still very active, where we awarded money from the NIH director to do just that. So it's a great question. What he's asked us to do is to merge our data on the metabolomics, the pesticides, the pollutants, with our data on the genetics, with our data on the epigenetics, with our data on all the exposures, besides the ones we quantitate, the pollutants, occupation, air pollution, the microbiome, and the immune system. And we are currently doing that. We have published individual papers where we've looked, for example, at the immune system, the microbiome, and ALS. Now, this is all in ALS. And we continue to pursue this, but it's challenging for many reasons. One is we're looking at someone's exposome now. But as I told you, it started on day one. How do you look at someone's exposure to metals and toxins throughout their lifetime? That has been a challenge. How does one know, what are the critical time points, particularly if you don't have clear measures of someone's exposure when they're, say, ages 5 to 10, 10 to 20. So they're really critical challenges in the field. Right now, we're doing it one step at a time. We had a paper a handful of months ago where we looked at, in our Michigan cohort, again, which is a large cohort, we looked at genetics, epigenetics, and occupation. We've looked at the inflammation, the immune system, and the microbiome. So we're taking it one step at a time, but the pie in the sky that we are going to reach is we're going to try to put it all together so that we could truly create an environmental risk score that would be translatable and help an individual. So we know your polygenic risk, your exposures, your occupation, your lifestyle. Here is your risk of developing ALS. That could then be translated to other neurodegenerative disorders, Alzheimer's and Parkinson's, minimally.
Given the associations between environmental exposures and neurological diseases, what policy changes or public health strategies would you advocate to mitigate these risks?
We are trying here in the state of Michigan to get ALS to be a reportable disease with the slogan, if ALS is reportable, ALS can be preventable. NINDS has also taken up the mantra that because neurodegenerative diseases are so complex, we should aim for prevention. Just the way the Lancet Commission has said 45% of risk factors can move the needle towards dementia. We need to change how we think. We need to go from always talking about cures and treatments to talking as neurologists about prevention, public health policy, cleaning up our environment, having public health mandates where we talk about exercise, we talk about the correct type of diet. We let people understand their exposures starting at an early age. Let's educate. Let's have new changes in public health policy so we can have true neuroprevention. They do that in cancer, right? They're trying to do it in dementia. the Lancet Commission. We need to do it for all neurodegenerative diseases. And it lies at the heart of the neural exposome, because that is the heart of all our exposures, and that will allow us to do prevention.
I think you've inspired us so much that we need this word to spread and we need to educate our legislators. And I think we really need to take on that work. Even we could go on hours and hours in the interest of time. What's a take home message from you on neural exposome and how it affects neurological disorders? Where do we go from here? In not just in terms of policies, how do we utilize in real life and make people's lives better and spread it to our community, including the rural communities?
Well, it's really what you said, and you've been on the Hill. I've heard you're very effective, Vinita. We need to change public policy. We need to really continue our investigation of the neural exposome, but we have enough strong clinical data in all of our patient cohorts to show that it increases the risk of disease. We need a Lancet Commission type paper for ALS, for Parkinson's disease, and then we need to move on those attributable risks and mitigate them. The population is not aware. Your patient and my patient doesn't necessarily understand their exposures and how they can promote neurodegenerative disorders. So it's on us to work with the policymakers to educate them for public policy change. And also, I think, for us to educate one patient at a time, which we try to do in our clinic. It's a very exciting field. It brings us from cure and treatment also to prevention. And I strongly feel that we'll see true traction in the next 10 to 20 years.
Thank you, Eva. Thanks for joining us.
I had a great time. Thanks for having me.
That was Dr. Eva Feldman of the University of Michigan, interviewed by Dr. Vinita Acharya of Penn State College of Medicine. ANA Investigates is the official podcast of the American Neurological Association. The show's producers are members of the ANA Education Innovation Committee, chaired by Michelle Johansson. I'm Adeline Goss, podcast host and executive producer. Our production team this month included Vinita Acharya and Jen Hurley. You can listen to past episodes of the show, subscribe to us so you never miss an episode, and access all of the ANA's educational programs on the Education tab at myana.org. That's it for ANA Investigates. See you next month.